day, stat students. So today we're going to talk about section 3.1, and we're going to get into more interesting things today because before we were just looking at one variable. Now we're going to look at the association between variables. All right, and so here's an example. Usually when I talk about this in class in the beginning, and I say, give me an example of a relationship between two variables, a lot of people automatically go to the association between two quantitative variables. So I have one up here on my screen. Is there a relationship between how long a student studies in hours and score on an exam, points. So they're both what? Quantitative variables, all right? And yes, we're going to talk about that in Chapter 3, but that'll be starting in Section 3.2. So how about this example, though? Is there a relationship between smoking and lung cancer? Now think about that. What kind of variables do we have here? Do you smoke habitually throughout your life? Yes, no. That is a categorical variable. And then lung cancer, categorical. All right. I think most of us realize that there's an association between these two things. And in statistics, we can go ahead and figure out, we can figure out that relationship, if the relationship exists and how strong it is, and so on and so forth. And so we can actually take a look at the relationship between two categorical variables. And actually, that's what we're going to go over first in 3.1. All right. And then I have a question like this: is there a difference in the genders regarding their average score on the math portion of the SAT? Notice there that you got there talking about score. That's a quantitative variable, and then you have gender. That's categorical. So actually you have one categorical and one quantitative. And so we're actually going to take a look at that relationship in Chapter 10. It's going to take a while to get there. We got to learn quite a few other things before we can do that one. But we can talk about example 1 and example 2, all right, in more details in this chapter. All right, so we talked about these two variables. We give them names, okay? And the first variable is the response variable. And you might hear this being called the dependent variable in another class. Same thing, all right? So response variable, dependent variable, same idea, all right? And we want to know why this variable is changing from person to person or thing to thing. So you'll get really some complicated definitions with regards to the response variable, but let's think about it like this, is that why did one person get lung cancer and another person didn't? Or why was one person tall and another person shorter? So on and so forth, all right? And so that's the response variable. Why is it changing, all right? The explanatory variable, aka the independent variable, we test whether the response variable is at least partially explained by the explanatory. So obviously the explanatory does the explaining, okay? So that happens, and the reason why we call the other one the response variable, because the response variable is in response to the explanatory, all right? So notice there I put partially explained. Usually in the real world, it's hardly ever we find one variable completely explains the value of another variable, all right? Or if you're talking about categorical things, you're hardly ever going to find one variable that completely explains why one person is one way and another person is another way. It's probably not going to happen. So usually we're just talking about partially explains, all right? And so in some problems, you'll need to identify which variable is the response and which one is the explanatory. And if you have problems figuring it out, try this one. Use time if possible, all right? If it's obvious which came first, that's probably the explanatory variable. Because remember, the response variable is in response to the explanatory. And so the explanatory happens first, and then the response is second. Now, sometimes you can't always use time, all right? I'm just giving you a a way of maybe figuring this out, other than just reading the problem and automatically figuring it out. And so, for instance, somebody smokes first, or doesn't smoke for that matter, and then unfortunately in response to that they may develop lung cancer or not. All right, and so usually if there's a time difference between the two, the explanatory is the one that happens first. Okay, so we're going to talk more specifically now about the association between two categorical variables. And so the way we take a look at this is with what's called a contingency table. Another word for this is a two-way table. All right, and so what it does is displays two categorical variables. Like I said, the rows list the categories of the explanatory, and the columns list the categories of the response. Now, I am setting it up this way so you never have to change the analysis. If you always put the explanatory as the rows and the response as the columns, you do not have to change the type of analysis that you do. You can just keep on doing the same type of analysis over and over. If you switch those two, then you got to do something different. Okay, and let's not go down that path. How about we just always put the in the rows the explanatory and the response in the columns, so we can do this analysis the same way. So the entries in the table are frequencies, and the intersection between a category of the response and of the explanatory, that will be a intersection, and I'll show you. It's just an individual set, okay? And I'll show it to you here in a second. So let's say that here's our example, that smoking and developing lung cancer. So I think we all agree that lung cancer is associated with cancer. Lung cancer is associated with smoking, but how do we know? All right, and so let me give you an example. And this is extreme. This is silly, but I think it kind of proves the point. Let's pretend if you smoke. Okay, now this is obviously not correct, but let's pretend that if you smoke, your chance of getting lung cancer is 98%. Well, if somebody told you that and that was actually true, what would you do? I think everybody would say, well, I don't think I'm going to be smoking too much, right? Because now, what are you doing? You're somehow associating smoking with lung cancer. So let's look at it in the opposite direction. If you don't smoke, all right, you only have a 0.1% chance of developing lung cancer. So notice the big differences there, okay? Huge differences, all right? So I think if people told you that, if the medical community told you that, and it was absolutely true, I think most people would say, oh, geez, that means smoking and lung cancer are associated, all right? One is dependent upon the other one, all right? And so, so like my statement says here, you wouldn't smoke because you associate lung cancer now with smoking. Why? Because, why? You have such a huge difference in these percentages here. You got 98% here versus just a 0.1% chance down there. All right. And so this is the key here in understanding when we can figure out if two variables are associated. A large difference in these percentages. So right here. So we got 98% versus 0.1%. Okay. It's literally on the opposite sides of the spectrum, right? Because you can't have over 100%. You can't have less than 0% with regards to this stuff. So a large difference in these percentages is suggesting that developing lung cancer is associated, is related, is dependent upon whether you smoke or not. All right? And so it's all about figuring out percentages, all right, and comparing those percentages. So I told you we're going to set this up in a table, and so we'll put, remember the explanatory. So remember the explanatory is going to go over here. So let me just put EXP for explanatory. So were you a heavy smoker or not? All right, and then this is the response. Okay, And the response here, unfortunately, is lung cancer. All right, and so those are the columns. Yes, no. So notice we have two categorical variables. Did you develop lung cancer? Are you a heavy smoker? Categorical. And so notice the cells here. So each one of these cells is an intersection. All right. And what does that mean? Well, what this means is that there was 210 people that, yes, they developed lung cancer, and yes, they smoked habitually throughout their lives. All right. And then let's say you look at this cell. That's saying 688 people did not develop lung cancer, and nope, they didn't smoke. Okay. And so there's our data. All right, it's just frequencies. It's just adding things up, okay, and putting people in these cells. All right. So probably if I got this problem, the next thing I would do is I would start coming up with some subtotals over here, okay. And so I would add up the 210 and the 490 to get to 700. I would get to 695 by adding those two numbers, but I would also add these two numbers here, 217. And then we got 1178. Now be careful with this number. This is the total sample size right here. And be careful with this one. Either add these two numbers or add these two numbers, but don't add all four of them. If you add all four of them, you're counting everybody twice. All right. So to me, the easiest thing to do is just to take these two numbers right here and just add them together, and you get 1395. Okay. So be careful with that one. All right. Total sample size. So what does this represent? There were 700 people that were smokers. There were 695 people that were not smokers in our sample. There were 217 people that developed lung cancer and 1,178 that didn't. This is not a real study. These are just made-up numbers, just to kind of prove a point to you guys. Okay, so don't go home and think you got lung cancer. All right, these are just made-up numbers. Okay. So I think what we want to do is we want to start isolating these different groups, okay? And so notice here, I have an arrow, and I'm going to isolate this group first, and then I'm going to isolate that group and then compare those percentages. So I'm going to compare the smokers to the non-smokers and the percentage of that develop lung cancer. So what's going to happen is that for homework and for the exams, we kind of lead you down to the correct way of analyzing this, okay? Ultimately, what are we trying to do? We're trying to figure out if there's an association between these two variables, lung cancer and smoking, okay? We're trying to figure out if there's an association between these two, all right? And we're going to basically lead you down the path to answer certain questions, and based upon those answers, you should be able to answer then, are these things associated or not, okay? So the first question that we're going to ask here, what percentage of smokers develop lung cancer? So by asking it like this, notice what we've done here. What percentage of smokers, okay? So we are not interested in the total. We are not interested in the non-smokers, okay? Who are we interested in? Of smokers. That's the English way of saying, hey, let's just isolate that group, okay? So that means we're just isolating the smokers there, all right? And so we are not looking at these guys here. What are we going to? We're just looking at the group of 700 people. So out of that 700 people, what percentage develop lung cancer? Well, let's see. Out of the 700, it looks like 210, okay? And remember, this is a percentage, and so it's got to be, between 0 and 1, or between 0% and 100%. Okay, so this would be 210 divided by the 700. Okay, you put that in your calculator, you get 0.3. Move the decimal place over 2 decimal places, you get 30%. So we know 30% develop lung cancer if they were heavy smokers, and without even thinking about it, what percentage of that group didn't develop lung cancer? If 30% did, that means 70% didn't. Okay, now so there's really no reason to actually calculate the percentage that didn't, because you can just do that subtraction from 100. Okay, now you couldn't do that if you had 3 groups. Instead of just having yes and no here, you had 3 or 4 groups, you couldn't just do what I did there. You would have to actually do the calculations there. But since we only have 2, you can just do the subtraction from 100% and you know the answer. Okay, how about what are we going to do next? So we know this group was 30%. Okay, this was 30. Well, what percentage of non-smokers develop lung cancer? Remember, we have to compare those 2 percentages. So what percentage of non-smokers? So who are we isolating? We're isolating this group right here. All right. And so we're not interested in the 700 anymore to answer this question. Certainly not the 1395, but what? The 695. So out of that group of 695, how many develop lung cancer? 7. So we would have 7 divided by 695, and that's roughly 1%. So we now know that this is 30% here, and this is 1%. And so we have to ask ourselves, is that a big enough difference so to say that there's an association between these 2 things, meaning lung cancer and smoking? All right. And so is that, you know, before I gave an example of 98% versus 0.1%. There's no doubt there. But is this a big enough difference, okay, to say that we're pretty sure that these things are associated? Okay. So we'll see. So I have a rule of thumb for you that I sort of created, and it's kind of spread throughout the stats department here. We're going to use this rule of thumb. If the difference between these 2 row percentages is greater than 8%, so you're going to have to remember that. So if the difference is greater than 8%, the variables are associated. They are related. They are dependent, meaning big differences means that, oh, okay, these things are related. All right. And so what do we have? Remember, we have the 30% for the one group. We had the 1% for the other group. So the difference means we've got to do a subtraction between the 2. So we're just going to subtract the 2. So notice what I did here. I took the 30% minus the 1%. We got 29%. That's greater than or equal to 8%. Okay. Oh, I see greater than or equal to 8%. The variables are associated. They are related. They are what? Dependent. All right. So if these were the numbers, we would say the variables smoking and lung cancer are associated with one another. They are related. They are, one is dependent upon the other. So I want to make this really, really clear. All right. In order to determine if the 2 variables are associated, always, always, always calculate row percentages for the different levels of the explanatory variable. So in other words, let's go back to our table. Do not do, in order to answer the question, are these 2 variables are associated, you will not calculate this way. So you will not ever calculate 210 divided by 217 and 490 divided by 1178 in order to answer the question, are these things associated? All right. The way the analysis will always be done is by rows, this way. Okay. That way. Row percentages. Remember, we took the 210 divided by 700. We took the 7 divided by 695. We did these row percentages. The book will call this conditional proportions and conditional percentages. I don't really care that you know that terminology. But if you run across that, that's what we're talking about, these row percentages. Okay? And so, always, always, always calculate the row percentages to figure out if these things are associated. All right? So I'm going to give you another example. All right? Just make sure that we got it. So, gender is the explanatory variable. Commute, response. Okay? And so to somehow, basically what we're asking here, is there a difference in the males versus females? Okay? Actually, I got them the other way. I got the females first and then males. Is there a difference in the genders with regards to living on campus or not? Commute, live off campus. Don't commute, live on campus. Right? And is there a difference between the genders? Okay? Just like we were testing before, is there a difference in smokers versus non-smokers with regards to developing lung cancer? Okay, well, we're testing if there's a difference here. okay, and the genders with regards to where they live, on or off campus. And so I've already come up with the some subtotals here. So we got 400, 600, 110, 890, and remember, you add these two numbers or add these two numbers to get the total sample size of 1,000. Okay, so we're going to try to lead you down the right path. What are we going to ask you? We're going to ask you first, let's look at this row. Let's look at the females. What percentage of females? By asking it of females, that means we are not interested in that group, we're not interested in that group, okay? We're interested in just females, okay? So out of that group of females of 400, how many commute? Looks like 50 divided by 400, that's 1/8, that's 12.5%. So we know that that group is 12.5%. What percentage of males commute? Okay, so now what are we interested in? We're interested in that group. We're going to compare the males versus females, right? So what we got there? We got 60 divided by 600, and that's 0.1. So is that a big enough difference? We got 12.5% versus 10%. Is that a significant enough difference to say that these two variables, commuting and gender, are associated? Well, is there a big difference? Now let's see. So if we do the difference between the two, we got 12.5% minus 10%, we get 2.5. That's what? That's less than 8%. Okay. So the variables gender and commute are not associated. They're not related. They're not dependent. It doesn't look like these two variables are based upon our random sample anyways. Doesn't seem like we can say that there's a definite association. All right. Less than 8%. By the way, let me go back for a second. Let's say that that the female group was 10% and the male group was 12%, and you do that subtraction there. Don't do 10 minus 12. Always put the larger number first when you do the subtraction. Okay? Do the larger number first always. All right? I don't want you to come up with a negative number for that difference, okay? This difference I don't want to be negative. So put the larger percentage first minus the smaller percentage, and come up with that, and then compare it to that, the 8% or whatever, okay? So here we came up with 2, right? And so then we got to compare that, versus the 8%, okay? All right, let's move on. So now, this is more for homework. I think for the exams, we're going to ask you some minor questions here to help you understand and answer the question, are these things associated? All right. This is more for homework, or maybe we could give you a question with regards to this on the exam that we ask about the total. So what percentage of the total? All right. So now, if you see this in WebAssign or maybe on the exam, that we're talking about the total there, all right? And so we got, and notice here I changed it around a little bit. Why not? So what percentage of the total does not commute? So that would be the 890 versus 1,000, and we got 89% there. So if they ask out of the total, that means we are looking at this row right here, probably. Okay? So I'm going to stress this again. Homework might ask you to calculate a column percentage, but those column percentages will never assist us in figuring out if there's an association. Okay, as long as we put the explanatory variable here and the response variable here, doing the analysis this way, all right, will not help us figure out if these things are associated. This is more something that the authors of WebAssign decided to ask you with regards to these questions, and there is some worth in it. However, in answering the questions, if the two variables are associated, all right, that will not, these column percentages will not help us. Okay, but could you run into a question like that on homework? Yes. All right. So it says here, what percentage of the commuters? Oh, okay. So here's the commuters. Here's, yes, they commute. And so what are we working with? We're working with that column right there. Okay. What percentage of the commuters are female? Okay. So here we have 110, right? Out of that group of 110, we got 50. I think if you figure that out, that's 45.5%. Okay. Again, a homework thing. There is some value in it, okay, but answering the question, are these things associated? Okay, these two variables associated, always rows, rows, rows. Okay, so that takes us to the end of this this section. Thank you for your time.